Hey, physics kids, Williams here, and I got a really short lesson for you about heat and phase change. So let's just take a look at a temperature graph. What are we looking at here? This is a graph of temperature on the y-axis, and we're seeing energy added constantly over time. So our x-axis is, you can think, the amount of energy added. So I could add even like some labels here of like 1, 2, 3, 4, 5, 3. Come on, there we go. 3, 4, 5, some markers on there. And this is a measurement in joules, right? So we have an object here, and we are putting some energy into it. And the object's temperature is increasing as a result. But what's interesting to notice is that during the times that we are at a certain point, the temperature remains constant, and then we continue to add energy in, and then the temperature changes very linearly. Every other joule we put in there, we get a corresponding temperature change. But again, we hit another point and we remain constant. Well, we can see here with 0 degrees Celsius and 100 degrees Celsius, our object is almost definitely some amount of water, of H2O. And we know that water freezes at 0 and boils at 100. So what we're seeing here is these phase changes. This is the period of time when the water changes from one phase to another phase. So if I start as a block of ice, I'm less than 0 degrees Celsius. Well, then it takes some time for all of that ice to melt, and then it turns into a puddle, and then that water's temperature is going to increase, and then eventually it becomes steam. And then again, it takes time for that water to change from a liquid state to a gaseous state. Imagine when you put water on the stove to boil, right when it hits boiling point, it doesn't all vaporize. It takes a while for all of that water in there to boil. You have enough water that it takes probably a solid hour or two of boiling before you lose all of the water that you had, before you turn it all into steam. So, all temperature, not just water, but everything kind of undergoes a similar graph. We'll have different slopes and different periods of constant. Oops, I don't want to do that. Sure, we can discard that. Different periods or like different lengths of how long it's constant, but all things take some time to change. So latent heat is the term that we give the amount of heat it takes to restructure molecular bonds in a substance to change from one phase to another. So this is just another example here, temperature versus energy, where we have a solid, we have a liquid, we have a gas, and all of them show that it takes some energy when there's no corresponding temperature change, and the energy that's going in is changing or restructuring the molecular bonds. It's a hard thing to measure because the temperature stays constant, like from B to C. How much energy did we put in there? Well, we can't just see the temperature change and get an energy out, but we can infer it a couple different ways. And we know, and we're not really going to talk about like how do we measure. We're not going to calculate the specific heat, but we can really just see it from a graph. And it's important to just know that it takes energy to change phases. We can be specific with, instead of just saying that's a latent heat, well, there's a lot of different kinds of latent heat. Like, for example, here we see two different phase changes, that it's melting and it's vaporizing or evaporating. And so if I wanted to be specific to the melting phase change, this is where we come in and start talking about enthalpy. And we have enthalpy, which is the same thing as heat, and that's why I put a slash here. It's either called enthalpy of fusion or heat of fusion, and that's the amount of energy specific, like the numerical amount needed to change from a liquid to a solid. We are fusing here. We're going from a liquid to a solid, so it takes energy to do that. And then same thing, enthalpy of heat of vapor or heat of vaporization. It's the amount of energy added to a substance to change it from a liquid to a gas. So enthalpy of heat really means the same thing. Both are forms of latent heat, but we're just being specific to like melting or freezing or condensating or evaporating. And that's really all I have for you guys today. It's just understanding how phase change diagrams work and being able to read it and see the periods where our temperature is changing and then when it's not changing, and why temperature might not be changing when we are putting energy into it.